Hey guys, we're going to start something new today. And so today, even though it's something new, it shouldn't be too bad because you're only going to do a small portion of kind of what we would usually do on a single day. But what I wanted to talk about is logarithms. So you may have not ever heard of logarithms. And the best way to explain a logarithm is it's the opposite of raising something to a power. So if I look at this example, 2 to the fourth power. If I was to ask you what is 2 to the fourth power, then you would say, well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power is 16. Okay, so 2 to the fourth power means 2 times 2 times 2 times 2, or 2 times itself 4 times, gives me 16. Whereas this is called a logarithm. And this is asking a different question. So, and this is how I think of this. I'm going to erase this real quick. When I asked you 2 to the fourth power, when I said 2 to the fourth power is what, I asked you basically to take 2 and multiply itself 4 times to get 16. What it's asking here is 2 to what power gives me 16. So let me say that again. This is, I think of a log as a question. 2 to what power gives me 16? Well, we just did this up here. 2 to the fourth power gives me 16. So in a log, it's asking for the exponent. Whereas here, I raise it to the exponent and get the answer. Okay, so if you want to think of this, this is saying 2 to what power gives me 16? 4. So it's kind of the opposite of raising something to a power. And I'll show you a few examples to kind of help this, bring this home. So if we go here, we have, this column is the logarithmic form, and this section over here is the exponential form. So you can convert from what's known as logarithm form to exponential form. And this is kind of how you do it. If you have a log here, to put it in exponential form, this is your base. So 2 is my base. So 2 is actually going to still be my base here. So my base doesn't change. My exponent is this number. So this is 2 to the fifth power equals 32. So if I want to convert this logarithm into an exponential form, the base stays the same. Your answer becomes your exponent. And the 32 here becomes your answer. And you can check because 2 to the fifth power is 32. So that should work out. And so again, let me explain what this is asking. So a logarithm, let me change colors here. It's saying 2 to what power gives me 32? Well, to the fifth power. Whereas this is saying 2 to the fifth power is 32. So I'm kind of wanting you to see there. Now notice, I did not write log here. So when you go from a logarithmic form to an exponential form, your new thing does not have a log. A lot of people want to write the log here, and you don't do that. So if I want to go from this to exponential form, again, my base is 5, so that doesn't change. So you would say 5 to the 0 power equals 1. So this kind of helps. I'm drawing almost like a little circle here. So when you're converting, I start with the base. So 5 to this power equals that number. Sometimes that helps to kind of think of it as a circle almost, where you start at the base and end back here. So 5 to the 0 power equals 1. Oops. Let's see. Okay, we got time. And so this, again, a log is basically the opposite of the exponent. Now, what if we're going from here to a log? Well, remember the base is still the same. So log base 2. So my base does not change. But remember what I said, the exponent is actually your answer. So when I'm having a log, whatever my exponent is, so in this case the 4, that's actually my answer. And then my answer, which is in this case is 16, goes here. And this is actually called, so I will use this terminology every now and then, but in a log, this spot right here is called the argument. Okay, so we would say the argument is 16. So 2 to what power gives me 16? 4. Okay, so that's what that's asking. Again, a log is like a question. And so basically, let me say this. When you're switching from one to another, the only thing that really switches is these two numbers. So what you'll notice is 2, 4, 16, 2, 16, 4. Okay, 5, 1, 0, 5, 0, 1. Okay, the only thing that really switches is these two numbers. And when you go from log to exponential, you get rid of the log. And when you go to exponential to log, you just add a log. So here, if I want to go from log to exponential, I just get rid of the log and switch these two numbers. So 10 to the negative first power equals 0.1. So again, whereas here, so let me say again, what we did is we just got rid of the log and then switched these two numbers. The 10 stays put and we just switch those two numbers. Whereas from here to here, I add a log and just switch the 4 and the 81. So log base 3 of 81 equals 4. And kind of to maybe help it make a little bit more sense, in the same way that multiplication is the opposite of division, raising something to a power is the opposite of logging something. So the opposite of raising something to the fourth power would be logging that function. But anyway, and so one more. Actually, we'll do a few more. How many time we got? Okay, maybe just one more. Now this looks confusing, but again, remember what I said. The base doesn't change, so we still have the same base. So we have log, and the base is still 1/6. Now I know that may look weird, but it's not too bad. And then we just switch these two numbers. So we would say log base 1/6 of 36 equals -2. So hopefully this helps. I'm going to create a few questions for you to get some good practice with this in, and let me know if you have any questions.